Good afternoon, everybody. I hope everybody's having a great afternoon. We've had some great presentations so far today and yesterday, and we're going to keep riding that wave with this esteemed panel that I'm privileged to be able to introduce you to. I think it's a nice segue based off of our morning presentations. We were talking a lot about, there was talk of fossil fuel. It's also important to talk about transitions and renewables, and we have a 2045 renewable portfolio standard that remains in place and is the law. So I'm really privileged to be able to introduce this esteemed panel. In fact, there's so much esteem. There's a lot in their bios, so I'm just going to go and introduce them by name and their role with the company, and then let them talk about all the interesting work that they're doing supporting the clean energy transition in Hawaii. First to my right is Bob King. He is president of Pacific Biodiesel. We have Jamie Ware, who is a mechanical engineer with PAR Hawaii. She's director of renewables for PAR. We also have Joel Simon Pietri, who is the president, CEO of and entrepreneur founder of Aloha Carbon. And we have Christyn Senda, who is director of project and business development on the clean energy team at Hawaii Gas. So I know we've got some really interesting presentations here where they're going to give us an update and where their technology is and what it's been doing in the energy sector in Hawaii. And I'll hand it over to Bob.
All right, thanks. Nice to be here and talk with you today. My piece is on biodiesel, and Bob King, I'm founder and president of Pacific Biodiesel here in Hawaii. We have a refinery on the Big Island. It makes 6 million gallons a year of biodiesel. Most of our feedstock is used cooking oil and trap grease from Hawaii, and we are moving into agriculture next to get more feedstock. The rest of our feedstock comes from the mainland U.S., mostly used cooking oil again. But trying to build the entire production for this plant from in-state in Hawaii. All of our fuel also stays in the state of Hawaii. But so biodiesel, it's a process of breaking vegetable oil. We use a distillation process which makes very clean, almost clear like water biodiesel that works great in these new modern clean diesel engines. Carbon intensity is less than 20. Typically we're like 15 or 16 carbon intensity, so it's much less carbon than diesel fuel. And when you look at the life cycle greenhouse gas of biodiesel, so the University of Southern California did a comparison of a transit bus in Hawaii using our biodiesel and electric, and the biodiesel was 41% lower life cycle greenhouse gas than the electric bus. So it's a good fuel to be using. It'll last 2 years in storage if you want to run power gen on it and keep it for that rainy week. It's an excellent dense source of fuel, and it'll blend with PAR's renewable diesel or fossil diesel as well at any ratio. So it's a real nice drop-in fuel. So again, I think on power generation, our main place to put it is in the efficient fast start diesels. These will come up and turn off really quickly within minutes, 2 minutes, and so you can optimize the use of the great renewables, photovoltaic and wind. Don't keep them running any minutes more than you have to. And they can do that as many times as you want during the day. But next step is really about growing some more fuel to max out the plant. So we've been, for a little over 10 years now, we've been farming in Hawaii. We just a couple of years ago moved most of our operations to Kauai. So this top is our farm on Kauai, out on the west side. We put in silos. Unfortunately, there's nothing here for oil crops in place. So we had to build everything from from end to end, from ground equipment to planting, harvesting, and processing. We've got a crushing mill that we can crush oil from oil seeds. It's about a 40-ton a day crushing mill. So we make both culinary oils and biodiesel and animal feed from the meal that's left over. The fields on the bottom, on the left is canola. That's our first canola field. It was fantastic yield. It was way more than we expected, almost double the production that they're getting on the mainland. Sunflower has been popular. They're just nice to look at, and and they're really makes a nice culinary oil as well. And then we put in a field of corn, non-GMO corn, and this is really for animal feed, for chickens and swine. And our next crop that I don't, because we haven't done it yet, but I'm getting excited about it, is rice. So we're going to try to put in 100 acres of rice this winter, and the good rice, the sushi rice, the really high-end Japanese cultivars. So food and fuel, and we have to have them both. So it does take money to do it, and it's hard work to do it. So and I'm going to stop on my time here, but really the support for going further with this is really touch and go. It's very difficult both on the federal and the state level to continue investing in this type of operation. So we're trying, and that's me.
That's a great slogan and very appropriate for right now. And as an engineer, I definitely appreciate all the balancing of the systems and using multiple systems. That's really fascinating and interesting and a win-win solution. So I'll pass it over to Jamie.
Thank you. Those are some beautiful canola oil fields. I need to grow some of that in my yard. Okay, great. So my name's Jamie Ware. I'm Director of Renewable Fuels at PAR Hawaii. So PAR Hawaii is a refinery in Kapolei on the island of Oahu that's been providing fuels to the state. If you drive a car, if you've been on a boat, if you've been on an airplane, if you have goods delivered, if you use electricity, you use the fuels that are produced from PAR Hawaii. We're really proud to deliver these fuels locally. I have a chart up there that just shows how we're able to locally produce different utility fuels, as well as all of our military fuels produced locally. And so one area that we're trying to tap into is how do we produce our fuels from renewable feedstocks, renewable sources. So the object of this presentation is to excitedly share that we, as of last month, began producing renewable diesel and other renewable fuels for the island of Oahu. So also about PAR Hawaii, we do have terminals on other islands. We have fueling stations. We own the Hele brand, and we employ about 650 people at the state. So with the next slide, I'll introduce the renewable fuels facility that is now operational in Kapolei. So we take a variety of renewable feedstocks, such as soybean oil or used cooking greases, canola oil, all those types of renewable feedstocks, put it through our unit, and the output is 61 million gallons of renewable fuels per year. So that is renewable diesel, which can be used for marine or transportation, and SAF, or sustainable aviation fuel, which is for the aviation industry. That process is, I think, very exciting from an engineering perspective way to make fuel. So we start with our existing infrastructure that we use to create the tankage and the pipelines. We then put the fuels through the renewable feedstock through a pretreatment unit, and that essentially removes contaminants such as phosphorus or other fertilizers that's used in the renewable crops. It then goes through a hydrotreater, which is in a reactor. We have high pressure, hydrogen, high temperature, and we use that to convert the fuel. It's very exciting. I would love to see a Netflix documentary on this sometime, but if anyone wants to talk about the engineering behind how it works, I'm here till 5. And then finally, you have to blend and certify it. So this is a picture of the fuel plant in Kapolei. One thing I think is really exciting about this is we shut down a fossil fuel unit to make this unit. So that's actually a converted fossil fuel unit. We did have to add a few towers and piping, but overall I think it really speaks to PAR's commitment to being part of the state's energy future by shutting down a fossil fuel unit and converting it to renewable fuels that is operational today. So a little bit about our feedstocks. Our unit can run a variety of feedstocks. We can use the heavier stuff, like use cooking oil or beef tallow. We can use canola oil, soybean oil. We do have to meet certain certifications. You do have to make sure you are using environmentally friendly feedstocks. So we have certain certifications we have to meet to make sure we're not running anything that could be potentially harmful. And then we do aspire to locally get our feedstock. So I think Bob did a great introduction to all the efforts he's spearheaded here in Hawaii to start, building that agriculture base. And so I'd like to demonstrate some of the efforts we've done. So the map on the up here shows different ag land that is available for producing of renewable feedstock crops. So I really just have this vision of the future. If we can get agriculture stimulated, we can start using these local feedstocks to make our own diesel and jet fuel on island. So we've partnered with Pono Pacific to help us figure out how this could look in Hawaii. We've also had investment from Alaska and Hawaiian Airlines. There's just so much interest between ag and airlines and the fuel providers on how we can deliver these renewable fuels to the island. I also think that this local feedstock production really supports just different economies across the island. I wanted to take a moment to recognize the team behind the pretreatment unit. So as I mentioned, pretreatment is how you remove contaminants from feedstocks. Hawaii is the first in the world to ever build this type of technology for pretreatment. Existing pretreatment units generate a lot of waste in the form of clays and powders. And when we visualized this project at Par Hawaii, we didn't feel comfortable with potentially generating waste that would have to either go to our landfills or be shipped to the mainland. So we innovated a brand new pretreatment technology that minimizes the yield loss to less than 1% versus conventional's 2 to 8%. When you look at our 61 million gallon per year unit, if we had to waste 5% of our feedstock, that's 3 million gallons a year that would go to waste. So bringing this unit online, we demonstrated that Hawaii could be first in the world for innovation. We have international visitors, people from the mainland now, all interested in this technology that Hawaii developed, which is really helping push the renewable feedstock world forward. So really excited for the team and excited that we could really represent Hawaii on our local developed technology and alongside our other partners with this. Quickly, our key advantages, so up to 80% greenhouse gas reduction. It depends on what feedstock you use. Different feedstocks have different life cycle carbon intensity scores, but this is Firm Energy. We also drop-in fuel, so this can go into our jet engines. It can go into your vehicles. It's not something that has to, we don't have to rearrange how we do all of our transportation equipment just to utilize this fuel. As I mentioned, we really want to look at how to use local feedstocks, help boost our local ag culture, and really create that circular economy where we're producing our fuels through locally produced feedstocks. There's a number of ways that our fuels can contribute to Hawaii. I won't go over all of them, but on island, there's many ways we can use renewable diesel, renewable jet fuel. It is molecularly identical to the fossil fuel equivalent, so there's many applications where it can be dropped in. Finally, I'd like to conclude that while I'm up here presenting our project, there is a whole team of people behind me that have supported this. They've had a vision to bring this fuels to Hawaii. Our team is really, really proud to have delivered this. We shut down that fossil fuel unit in December of 2024, and as of April 2026, last month, we are online making these fuels. So really think it speaks to the creativity and ingenuity that we can do when we come together as a team to offer solutions. And lastly, when you fly into Honolulu, look for the bright green tanks. That's our new tanks we built to store the various feedstocks. You can see it on your approach in, and we're all really excited to share with our ohana and our neighbors about the work we're doing, and I really appreciate your time for this presentation. Thank you.
Okay, thanks, Jamie. It's super exciting to see it actually up and running. So, hi, I'm Joelle Simon-Pietri, and yes, I'm the founder of what we've branded as Aloha Carbon. It's making renewable natural gas on Oahu from waste generated on Oahu for use on Oahu. And it's actually a project of my small business, Simon-Pietri Enterprises, but I don't expect anybody to be able to spell or pronounce it, so Aloha Carbon works. Okay, so there's a couple different drivers behind what we're doing, and the first one shouldn't be a surprise to anybody in this room. Fossil energy is costly, and not just in the dollars for the actual physical fuel. It's also costly in other ways: climate, security, the amount of money that we've spent on wars alone for the United States. The second one I want to touch on is, you sort of got a sense of it from Bob and Jamie. There's an aspect of, intersections with other industries when you get into biofuels. For them, it's, and for their supply chains, it's agricultural, trying to grow the food and the fuel simultaneously and have that integrated system. For us, it's waste. I think that taking trash and putting it into a hole in the ground and calling it good is a crime against humanity and against the planet. And on Oahu, there are 2 landfills. Both of them have been headline news for the past month because they're both nearly full and going to have to be able to close. And expansion of either of them is highly controversial. The construction and demolition debris landfill in Nanakuli is surrounded by the largest Hawaiian homestead tract in the entire of Hawaiian Islands. It's a community of 22,000 people who delivered an 18,000 signature petition against the landfill expansion. And so, I was at that community meeting, opposing the landfill expansion. And, fast forwarding to now, 6 years later, we've been working on actually developing a solution for that. So our technology is to divert waste from the landfill basically, rather than do it out in Nanakuli, out on the west side of Oahu, where there's only one road in and one road out, actually bring it into Campbell Industrial Park, where we're surrounded by industrial activity, and take it through a refining process similar to a different technology, but similar to what you've already seen from PAR and Pacific Biodiesel. So, we plan to receive waste straight off the truck, straight from the job site, have a sorting plant to separate out what's recyclable, like the scrap metal, also what can be turned into new product, like plastic that can be made into composite lumber, and then what cannot be recycled and does still have an energy value, which is mostly treated lumber, that goes into a gasification system. Then the syngas re-refine and then put through a catalytic process of methanation to turn into a methane or renewable natural gas. And then the final step is a cleanup to get to a pipeline quality renewable natural gas that could go into Hawaii Gas's pipeline. Again, siting is really important. I don't think of us as a project developer trying to ask a community to let our project in. We're trying to answer a call from a community to get a problem out. And so we're moving the nexus for construction and demolition debris on Oahu from the rural community of, Waianae and Nanakuli into the largest industrial park in the state, Campbell Industrial Park. We're across the street from where AES used to be, 1 block away from H-Power, in between the 2 refineries, PAR East and PAR West, and in between the 2 scrap metal recyclers, and we're basically right in the middle of a solid waste management campus. So it's the right place to be at the right time. So our site actually is an abandoned former concrete batch plant. The previous tenants went bankrupt and just left everything in place. Tools still on the benches, paperwork still in the office, and the gates were locked for 10 years. So in addition to trying to do the goodness of renewable fuel and waste management, we're also just cleaning up this brownfield mess. And so what's on the left is what it looked like when, the day I signed the lease, and what's on the right is what it will hopefully look like once I actually raise the money and we actually develop the plant. So to get from here to there, this is a first of a kind innovation. I get the question a lot, well, where else in the world has people been doing this? Where can I go see a plant like this? And the answer is, you can't. We invented it here to solve problems for Hawaii, in Hawaii. But the good news is construction and demolition debris isn't very different. Once we prove it out here, we actually have a pipeline of projects on the mainland. So we're working on a second project in Tacoma, Washington, and stuff like that. So our journey since 2020, when I launched Aloha Carbon, has been focusing a lot on the physical testing. We've proved the entire process out on real-world waste shipped from Honolulu. Our partners at West Oahu Aggregate, Georgette called it the most expensive rubbish in the world because, you know, it came to us, it went through 5 different steps, got to be shipped from us to Washington State University to turn into pellets, then shipped to the University of North Dakota to run through their pilot gasification plant. That's the process that you're seeing here. And in between, it got shredded up by Island Recycling on their car shredder, so we also had to add this additional step of pulling all the extra car parts out of it in order to get it to run through the rest of the systems. So a little bit of tutorial on greenhouse gas life cycle emissions for those of you who aren't familiar with it. How it's done in the fuels world is you have a benchmark of fossil fuel. And so that's what's shown on the left-hand side with the big red bar. So that's kind of the benchmark of fossil natural gas, either liquefied natural gas or gaseous delivered by pipeline natural gas. And the 3 smaller bars to the right are the carbon intensity that our consultant has estimated that our fuel will be. So the first one to the right is for our renewable natural gas. That's if we actually use grid electricity for the parasitic load for the plant. If we cannibalize some of our syngas and make our own electricity, then we get to the second bar. We actually have gone from about 10 grams of carbon dioxide per megajoule of carbon intensity, or a 91% lower emissions rate compared to, say, gasoline. We've actually gone slightly below zero. And then if it were to expand to include municipal solid waste and avoid landfill gas emissions and the methane from the landfill in Honolulu, then we actually go even further below zero. Another aspect in there also is that the carbon that is in the ash from our process is actually permanently sequestered in mineral form. It's graphite and magnesite. It's not going back out into the atmosphere in anybody's imagination or technical process. And so we're able to actually count that for the carbon intensity reduction as well. So as far as price, which is the next biggest question. So what I'm showing here are sort of some example offers to gas utilities on the US West Coast last year. And how it's priced in the market on the mainland is renewable natural gas is actually priced by its carbon intensity reduction. So in the upper left-hand side is the most deeply below zero, usually from a dairy manure, because dairy manure is highly methanogenic. And so that's priced at $50, $60 an MMBTU. Then as you move to the right, you get, still below zero, but not quite as, juicy, is like the landfill gas and wastewater treatment plants. And so the price goes down accordingly to about $30, $25 an MMBTU. And then to give an idea for scale and price and context, this is how much we would make from one Aloha Carbon facility in Honolulu. It is a different scale. It's actually in large part because we skipped the landfill step. So if you take a ton of trash, you put it in a landfill, you get about 2% of the energy content back out in landfill gas, because those anaerobic microbes really are only running off the proteins and sugars, and then they run out of food and eventually die. We actually take the whole thing, turn it all into a synthesis gas, and then refine it into a methane. So it's actually more yield per sort of geographic area or per city than you get from the traditional renewable natural gas sources. So a lot of stuff has happened in the past 10 years to make this possible. We are standing on the shoulders of giants. We do have our own patents, but there's been a lot of development in gasification technology and its maturation in Europe and in China. And we have a world-class technology partner in Topsoe that is able to provide a full warranty for the methane process. And here's a little snapshot of my very small team on Oahu, but tiny but mighty. And I'll pass over to Christyn.
Thanks, Joelle. Hi, everyone. I'm Christyn. I'm with the Clean Energy team here at Hawaii Gas. And so now we've heard from different producers of renewable fuels, and that's been the focus of this panel. I want to shift a little bit because Hawaii Gas is different, but we play a complementary role where we're not only involved in the purchasing of fuels, but all the way through supply to our over 70,000 customers statewide. Okay, taking a step back, though, in the gas utility industry, I'm really proud to work for Hawaii Gas as someone who's been born and raised here. My family's been here for generations. It's really been an awesome experience to work for a company who's been supporting the state for over 120 years and has been a leader in this space. Today, we blend up to 15% hydrogen, which is one of the highest in the nation, and other utilities are looking to us as a model. We also blend up to 3% RNG, or renewable natural gas, through an innovative partnership with the city and county on Oahu, where we purchase the raw biogas from the wastewater treatment plant there and upgrade it to pipeline quality gas. Similar, just in terms of scale, I do want to point out that Hawaii Gas is also very small but mighty. We make up less than 5% of the energy share here in the state and less than 1% of the state's greenhouse gas emissions. But we have been really steadfast in supporting the state's clean energy goals. At the same time, we're focused on reducing our carbon intensity even more, so beyond what we are doing today. And I do want to note that we are required to file our CI score regularly with the PUC, and our carbon intensity is actually significantly lower than the benchmark that was shown earlier. And lastly, as a utility, we have a responsibility to maintain exceptional reliability and affordable for all customers. This is really shown recently during the Kona low storms. Our utility customers didn't have any disruption in service, and we were also able to provide backup generation for first responders on the North Shore. And with ongoing conflict in the Middle East, energy bills are at top of everybody's mind. Okay. In terms of what we're doing recently to make progress across the entire value chain, for procurement of supply, we did a competitive bid process and selected 2 projects that will be sited locally, a green hydrogen project with Eurus Energy Americas and a RNG project with Banna Pacific. For distribution, we announced a hydrogen transportation and storage pilot with a company called Ayrton Energy. They're using a technology called Liquid Organic Hydrogen Carrier, or LOHC for short. It's always a mouthful. But we're really excited about this because it's become a lot more commercially feasible in recent years, and that's always been the biggest barrier for the hydrogen market in terms of cost of how to move and store hydrogen outside of pipelines. And so if that proves successful for Hawaii, then that really removes a critical gap. And lastly, in terms of demand or customer adoption, we also recently filed the state's first renewable gas tariff with the PUC, and it's designed to be an opt-in program where customers can choose to support the purchase of renewable fuels without shifting costs unfairly to others who don't want to participate. So all of these together show how we're supporting the entire ecosystem of renewable fuels and not just focusing on a single fuel or technology, but trying to make the system work sustainably as a whole. Okay, in terms of challenges, I think this is touched upon a lot in this conference, so I don't want to dwell on it too much, but I do want to note in the gas world, we experience a lot of similar issues as the electric sector. In terms of RNG, we have the same challenges of intermittency similar to solar and wind, and so we constantly have to think about backup fuel and storage for security of supply. At the same time, changes in policy for tax incentives and supply chain can really impact overall project costs and therefore customer bills if not managed appropriately. And so as a utility, there's different ways that we're addressing this. One is to diversify our fuel sources to manage volatility. Another way is to leverage our existing assets to really minimize additional capital investment. Looking at projects in terms of how can we mitigate project and technology risk. And lastly, providing options for our customers so we don't, again, unfairly shift the burden to others. Okay. So in closing, I want to, if anything, I want to take away that Hawaii Gas is really we're the enabling infrastructure to make the system work. And so we view ourselves as a part of the system, wanting to work with all the players here at this conference. But at the same time, we're going to continue on our path to pursue low carbon initiatives and also support the state's clean energy and energy security goals. So I thank you for your time, and I look forward to the discussion.
Thank you. What a great synopsis of all. How many of you knew all these interesting things were going on in the state? I mean, I feel like I got a great education here this afternoon. Always learning something new. And as an engineer, definitely appreciate all the process and all the thought that goes into feedstock and the energy production pathway, and then all the benefits of how this can address all of where we're trying to go as a state. And that leads me into, I think, an interesting question. We have all of the leading energy minds in the state and the businesses and the regulators. And I guess for the panel, maybe starting with Christyn, and we'll work our way down, what do you guys, and you touched on it some, Christyn, but what do you all see as the policies that the state should have in place that would enable more quantity, get things in faster, even more cost effectively address pricing? What do you think we need to help keep that momentum and keep growing that momentum?
Sure. I know, so policies also often focus on, tax incentives and costs. I think as a utility, we want to just make sure that the cost allocation and equity is fair. But beyond that, I think there's a lot of opportunity to improve public-private partnerships and how we can move faster, and permitting. I think those are all things that are within the state and city's control. I think we would want to focus on that.
Well, good news is a really significant piece of policy for energy for Hawaii actually just got passed a couple weeks ago, and that is a clean fuel program. So a first for Hawaii. It's a major development, especially for the fuel industry. So really hoping the governor signs it, really hoping that maybe we get invited, all of us. From the renewable fuel industry. And there's some housekeeping that we're going to need to do, hopefully next year, because, for example, right now, natural gas doesn't qualify as a renewable fuel under that particular piece of policy, but that's the good news. Then there's also, the state has a renewable fuel production tax credit, which Bob has, lots of experience with, and so probably can talk more about. I think to echo what Christyn had to say, I mean, for me and my company, our biggest need is capital formation. We're trying to do, world-class, first-of-a-kind project in a market that doesn't really have capital sources for that kind of thing. So, and I've even looked at, special purpose revenue bonds and doing a pollution finance control authority financing, but it looks like it would take 5 years to just get the financing, and we would rather actually be breaking ground in one. So I don't know.
With renewable fuels being newer on the technology side, they are inherently more expensive to produce compared to fossil fuels. And so in order to make them feasible for our customers, we do rely on having certain tax policies in place. In California, in the West Coast, there's a number of policies in place that really support renewable fuels being economical for the companies and consumers. And so having Hawaii adopt a similar type of policy would really help keep those fuels in our state and make sure that we can get this newer technology fuels in the markets and support that usage.
All right. I think on our side, the key really is getting ratable use for fuels, and it goes both to the economic and the actual physical offtake of material. We're often in ups and downs in cycle, and that makes it, and right now it's a down cycle with the federal government, no surprise, pulling a lot of incentives away from renewables. So our production is very low right now. And and trying to find the market to get that fuel into to keep the business running. Without a steady market and a steady profit, it's extremely difficult to get any new investment in this industry. So if you're thinking somebody's going to come in and spend lots and lots of money, it's very risk-taking, as some know. It's very risky, and these are investments that go for 10, 20, 30 years, and 1 year, 2 year credits are just not going to get it.
Oh, that's great. So hearing a lot of what we need is a lot of certainty injected into the marketplace, and those are great points, and the right room to talk about this in. So we talked about those challenges and getting the regulatory aspects covered, and the support from businesses, and just the whole energy ecosphere. Where do you guys see as your biggest opportunities? And there are a lot of them. So I mean, what would you be able to share and elaborate on that with the rest of the group? You could lead. Go ahead.
Okay, I'll start. I think the biggest opportunities that we see is in the agriculture side. There's a lot of fallow land around. It's just a shame at how much water and land we have in Hawaii that's not being utilized. Yet we pull our resources from other places that maybe even have less than we have. So we got to get those lands back in production. We're looking actually at because the fuel and energy space is so fickle and up and down. Really, the food space might be what makes this all work. So we're looking at animal feed, say rice for human food, other markets that we can rotate in with our oil crops to balance that economic picture.
Economic volatility, right? Yeah.
Well, I'll echo Bob's statements with having a locally sourced feedstock for these renewable fuels initiatives would be just really good, amazing goal for PAR to be able to source those locally. Our first unit is 61 million gallons a year. It is it is smaller. We have the opportunity to scale that up once we can prove out our success with all that. And so I see a forward opportunities. How can we continue to utilize our existing assets and infrastructure to continue down towards the state's initiatives?
Well, every cloud has a silver lining, so, and never let a good crisis go to waste. So oil prices are up, yay! The landfills are almost out of space, fantastic! Fertilizer prices have doubled in the past 4 weeks. We have a solution. I feel like lately, you remember that ad? We have an app for that. I feel like that's kind of my answer to a lot. It's like, well, we're doing that too. We can do that too. We can do that because it's an integrated, we're taking stuff that is being thrown away and just repurposing it into something that's valuable. So that's the opportunity we're trying to go after. For the fertilizer side, which is not what I'm here to talk about, but the only things holding us up are permits and working capital. So, but everything else, the equipment's already on site. We've already proved out the technology. We've got crop trials in the ground, growing lots of delicious lychees and lemons. So lots of good stuff going on opportunity-wise.
I think for Hawaii Gas, we're still really excited about hydrogen, even though, on a federal level, maybe it's slowed down. We're really unique because we produce our own hydrogen here at our SNG plant on Oahu. And with this pilot with Ayrton, we could really scale that up and impact the transportation market, specifically the heavy industrial side that hasn't been tapped before, and that could make a really big dent on emissions there.
Oh, those are all great points, and share that. And I think it's a nice segue into talking about you guys have touched on it some, the technology that it's being developed. Joel, you were highlighting this, and the work and technology is being developed here in the state, and it's locally produced, and there's an advantage to that. And there's a lot of alignment in terms of, I think it would be great for the audience to hear just really where you see the biggest alignment with our goals, our state policy goals in terms of getting off of fossil fuels, our energy security as a locally produced energy source. addressing the cost. As the cost, you keep taking the steps to bring costs down. And then local, it's the support of the local economy as well. Those are all some key points. And, could you elaborate for the audience on just how much all of you are doing with that? I guess we could start with Jamie this time.
Can you repeat the question?
So I guess
want to make
touching
sure I
on,
answer it
no,
correctly.
that's we'll do. It's focusing on all the key, the alignment with all the key policy pieces that we want to go with in terms of generating renewable fuels or renewable energy in general. So there's the aspects of getting off of fossil fuel. There's the energy security piece, having it having it sourced locally. What we're doing to be cost effective is always a focus. And then especially the supporting of the local economic development.
Yeah, so policy plays such an essential and key role into helping these technologies really get off the ground. And with our sustainable aviation fuel we're making, it is more expensive to produce. When you look at the airlines, maybe they have a 3% profit and 75% of their costs are fuel. And so when we go and introduce a fuel that does reduce our carbon emissions up to 80%, but it is more expensive, how do we bridge that gap between us as the supplier that had to spend a lot more money to produce it, and then our customers who want to use those fuels. So I see policy there to help bridge the gap. Really looking at California with some of their policies, they have been able to use so much renewable diesel and renewable fuels compared to their fossil fuel consumption, and a lot of that has to do with the policies they have in place. So I think policy can be really powerful to how these fuels get into our local economy and utilized.
One of the things that, kind of like our innovations of the solid waste to fuel aspect is price stability, because our cost structure is almost entirely capital cost. There's very little feedstock cost. And so Russia invades Ukraine, our price won't change. The Iranians close the Strait of Hormuz, our price still isn't going to change. What would change the price would be a major event like COVID, where there's just plain less trash production. But in the case of COVID in particular, every single hotel that shut down actually renovated. So they actually used up 10 years of airspace at the landfill in 2 years because of all that renovation. So what I'd love to do is take a little strip stream of the money that I need to build Aloha Carbon and actually acquire the landfill and mine it and get all of the material back out, and that'll be our bank for low years of supply.
For Hawaii Gas, I think we have a unique position because we're able to look at a variety of different options. And so we need to balance, the decarbonization with affordability and reliability, and that's a really tough problem to solve, as everyone probably knows here. And so, it's constantly evaluating each project with due diligence and understanding that there's no going to be a single solution, and that we have to be creative and work with everybody here.
I think on our side, there's a couple sides. One is that rateable offtake of biodiesel. So it would be nice if there was an amount of biodiesel that was going into our fossil diesel supply. We tried to do a B5 mandate, just 5%, one of the lowest in the nation. That didn't pass through the state legislature. So we're trying to evaluate what does that really mean for desire to go renewable. On the agriculture side, there's some exciting pieces, and I think the numbers are looking really good, except that we have to create the entire infrastructure from scratch. On the mainland, we could just grow the crop and take it to a mill, or the mill could take their materials to someplace else to make it into feed or whatever. Here we're going to have to do the whole thing. Once we get it done, these pieces last for generation. It's a very substantial investment to bring our lands back into a new agriculture that is really a nice, diverse part of our economy. It's a substantial amount of both food and fuel that is not tourism related.
Right. So a lot of transformation needed, and we're in the process of that transformation and keep that momentum going forward. I think we could turn to some audience questions now. Let's see, sustainable aviation fuel questions. So I guess, Jamie, this would probably go to you. So a significant percentage of our emissions are associated with long-distance aviation. I think that's a big part of the emissions for the state, and either, I guess, in both the shipping and also well, I guess that's shipping, but aviation fuel aspect too with the planes. Are we able to generate enough volume of sustainable aviation fuel to support the industry? Do we have that capacity without compromising food production?
Yeah, good question. Our new unit can produce 4,000 barrels a day or 61 million gallons a year, but that is a mix between RD or renewable diesel and SAF. The SAF portion is smaller than the renewable diesel. So the current production that locally can be produced would not supply all of the long haul flights or all of the aviation fuel here in Hawaii. I think as this renewable fuels can expand, we can look towards bolstering that. I really think that the initial unit was there to get us into the renewable fuel industry, start providing these fuels, and don't let the long-term game of you can't produce all of the SAF for the island. We have to start somewhere, and so no, right now we cannot produce the state's full demand of jet fuel for sustainable aviation fuel, but we are working our way towards that. For the food versus fuel decision, so part of our feedstocks do have to our feedstocks do have to be certified to be, within the environmental agency's approval. So, for example, we can't use palm oil. Palm oil has shown to deforest areas. It has different, labor critiques, and so making sure we have our certifications for the renewable feedstocks we run help ensure that we're using the right feedstocks to support the local agriculture and area. With the feedstocks that we intend to run, so I think some of the feedstocks Bob has been growing, camelina, for example, grows very, very quickly here in Hawaii. It's drought resistant, so it doesn't require a lot of water. It also is a cover crop, meaning that when you plant it, it helps put nutrients back into the soil, so it can help invigorate that soil. And so using certain crops that help, support all of those things are what demonstrate that we're not fighting food versus fuel. It can go in parallel. Bob, I'm going to put you on the spot. Do you have anything to add to just that food versus fuel discussion?
Yeah, I think that's really been an exciting piece for us. When we get the Big Island plant 100% local sourced fuel, which we can do with fallow ag land, and if we had 2 rotations of oil crop and 1 rotation of, say, rice, that 1 rotation of rice, by the time we get our biodiesel plant full of fuel, that 1 rotation of rice will provide all the rice needed in the state of Hawaii, which is 130 million pounds a year.
That is impressive.
I had to do the numbers several times.
Can I be a little less polite?
Yeah, go for it.
Food versus fuel is a myth. It's a misconception. The economic reality in the industry is these are like, if you grow a corn plant, we eat the corn cob, but the rest of the plant still goes somewhere. It goes to fodder, it goes to forage, then there's dried distillers grains that also goes into hog feed. So they're actually integrated systems feeding each other. You get food and fuel and energy and fiber all from, reuse of these resources. So it's kind of a misconception that you have to choose. Really, you have to choose between status quo and trying to improve on the status quo.
Yeah, I'll add another aspect that I found just really interesting when I was first learning about the feedstocks is, a camelina seed, a soybean, it might have 20, 30, 40% oil. That's what's extracted to use for these fuels. But the rest of the soybean or whatever feedstock it is used as meal for animals. And I know Hawaii imports a majority, if not all of its feedstock for animal livestock, and so being able to grow that feedstock here, extract the oil for our fuel, use the meal for livestock and animals, I think is just such a beautiful circular picture of what the the aspirations and our vision is here.
And it's been another crisis, using the crisis. The animal industry in Hawaii is getting hurt pretty badly right now. The price of bringing in animal feed from the mainland has gone up, I don't know, maybe 40% in the last few months. It's the price of fuel. The ships and the trucking on the mainland costs money. So it does open up that opportunity for us here to grow more feed on these lands, but we need all the equipment, we need the infrastructure, the silos, the dryers, the things like that. So it's, but it's there, and if you want to see an industry that goes into crisis quickly, it's if you got a large egg operation and you can't get feed, you have a very, very serious problem immediately. It's so that's an opportunity for us to really take that. I was at a fats and oils conference in Chicago a month ago, and they were talking about nationally in the United States how valuable the biodiesel industry has been and renewable diesel industry has been to poultry and swine manufacturing. Our poultry and swine in the United States is super low price compared to anywhere else because of our renewable fuel industry. So when renewable fuels cuts back, that's the other group that complains, is the chicken and swine. Cattle somewhat, but those two are totally dependent on renewable fuel industry for our food that we like.
And those are great points about the integration of all the systems that we rely on, not just for energy, but for critical needs as well, like feed and growing cattle and all those necessary things. So one more question. Here's another question we have. This is getting more on emissions, so GHG emissions, and biofuels can. The question is centered around biofuels can kind of get grouped together as everything's biofuel, but as you guys have pointed out, there's many different ways. There's a plethora of processes. There's a plethora of feedstocks. Are you able to talk about what energy production pathways? When you're assessing a biofuel, how do you guys go about assessing the GHG reduction benefit?
I can go first.
Okay.
Yeah, I'm sorry. Yeah, so we have a way to calculate our carbon intensity score through the life cycle of the feedstock, and so we have it specific for the unit that we have here in Hawaii. We take we have to take everything how the unit performs, and so you can generalize CI score into different feedstocks, but our unit in particular has a unique score associated with each feedstock. Ideally, we want to run lower carbon intensity feedstocks, which would be more on like the used cooking oil, fats, and greases, which can, for our unit, can have a CI score of 20 to 30, whereas vegetable oils, such as soybean oil, camelina, would be more in the 30 to 40 range, and that's all compared to traditional crude oil, which is 95. So we do want to aspire to use the lower carbon intensity feedstocks, and then we have different calculations that are certified on what those CI scores are.
I'll jump in on that. Again, used oils are low GHG, low carbon intensity. But if we farm like we're doing here in Hawaii, we're using biodiesel to run the tractors. Our crushing mill runs on hydropower. It's behind the meter on hydro. Joelle could make me some more fertilizer, and we get rid of that piece. We're putting biomass into the ground. I do believe we're going to pencil out carbon negative.
I mean, for Hawaii Gas, like I mentioned earlier, the PUC requires us to file, third-party verified life cycle analysis and CI every time that we purchase a fuel or make significant capital investment. So that's something we do on a regular basis, and it's very transparent. I would have to do in the future as well.
I guess from my perspective, like for example, one of our neighbors, in Campbell Industrial Park, shreds tires. And they had been working on trying to shred tires for AES to be a substitute for coal. And, while I would love to help them out, I've had to explain that, well, tires, only 4% of the weight of a tire is biogenic natural rubber. The rest is a petroleum product. So I can't call it a renewable fuel in honesty. So it's the kind of thing where, like, I could accept your shredded tires. We certainly could make it into a fuel, a liquid, pipeline quality fuel, but I would have to actually discount that as just a fossil fuel. On the positive side, we can do, operationally, we can do substitution. So I'm going to have a whole bunch of, excavators and skid steers running around our yard doing all that sorting of the waste. Am I planning on using biodiesel? Hell yes. I'm planning on using 99% of Bob's. I would do 100%, but he needs the 1% blender's credit, so we'll let him have that. Which, by the way, needs to be renewed by Congress. So do you want to talk about that? Or are there more questions we should answer?
Maybe one more. I think this is more for Christyn quickly, and then maybe if you guys want to have one last word about what you want to share with the audience. So it's just a general question. I know the hydrogen, the question's about who uses the hydrogen that you're making, and maybe I'd frame it as most of it's in the pipeline. Do you have any direct customers, and do you have more plans to increase hydrogen production?
Great. Yeah, that's correct, Michael. Today, we produce hydrogen at our SNG plant Oahu, and it's blended in our utility gas pipeline. Oahu, so it's distributed evenly there. But with our pilot with Ayrton, we could do, specific direct to customers, and that's where we could really scale up hydrogen as well in different sectors.
Okay, so we've got about 4 minutes left, so I say go for it with the elevator pitch on, hey, this is why we're the greatest thing since sliced bread. So take it away, Bob.
Well, thanks. Thanks for being here and listening. And I just think, 31 years at this, and we're still educating. We're still trying to get to that vision that we've had a long time ago. And I wish we were there much further ahead than we are today. But we're trying what we can, and these things take time, and we are impatient.
No, thank you so much for having us. It's really been an honor to get to talk about some of the exciting things we're doing, and it takes, all the, different diverse types of renewable fuels or renewable energy types to really make all this work. It's not one fuel or one type suits all, and so happy to be a contributor to the state's initiatives.
So yesterday, Rocky took the opportunity with the microphone to talk about a crisis that's emerging, and that's the investment tax credit, on the state level, now compounding, its cancellation basically on the federal level. Unfortunately, we have the same thing going on in biofuels. So there were a whole bunch of federal renewable fuel production tax credits that were enacted with the Inflation Reduction Act during the Biden administration. With the One Big Beautiful Bill, half of those were reduced or eliminated. So the hydrogen production tax credit was canceled outright. The renewable fuel production tax credit was actually extended, but only to 2029. And in order to qualify for it, a facility has to be built and delivering fuel by December 2029, which is like tomorrow, as far as capital-intensive projects like this. And then also on the federal level, just 2 weeks ago, the EPA has decided that the fuel that Bob makes no longer qualifies for a renewable identification number, which has a huge impact on pricing. So I don't know if you want to add to that, but call your congressman, people. So if you want to add to that.
Yeah, so that was about 75-80% of our fuel went into power generation, and with that not qualifying anymore, it makes the price much more expensive for power gen. So now we have to go back to on-road, and that's a more difficult market to capture at where we're at. So we've had a triple whammy on economic factors this year that we're trying to deal with.
Like I said earlier, as a utility, our priority is really on keeping the system sustainable and supporting renewable fuels of all types and supporting the state's goals. I think it's a really tough problem that we're all trying to solve, but decarbonization, only works if the system remains safe, affordable, and reliable. And so that's our plan to continue pursuing that effort.
And with that, I'll say thank you to our panel members, safe, affordable, and reliable. You heard it. Thank you.